dr minus of lm by zr into pi dr iqs, isn't it? Pi dr iqs minus of pi qr I ds. Okay, this IDS and the IQS, these two terms are easily measurable. You can easily measure it actually. Okay, so if you draw the block diagram, just write down this equation very carefully. Then only you will be able to draw the block diagram actually. Fine now. How to simulate this speed sensorless vector control. Okay, and this one is a open loop vector control actually. Why open loop? That I will tell you now. Why open loop? Because in closed loop you can actually that this theta e in closed loop vector control, what happens is that you need to, this one is phi dr, this one is phi dr, and this one is phi qr, and you need to make the, and this is the angle between phi r, the angle between phi r and the phi dr comes out to be theta e. Okay, in order to have vector control, what you need to do is just make the theta e equal to 0. Then only you can say that the phi r is always getting attached with the phi dr, and thereby the machine can be, the torque equation of the induction machine will get reduced down to just as if like a separately excited, fully compensated DC machine, and thereby you can achieve the vector control. But here there is no mechanism like that. The mechanism is absent. Okay, so that's why it's an open loop speed sensorless vector control. And after completion of this one, I'll be teaching you the closed loop speed estimation, or might be you can say it as vector control. Vector control is only possible when you make theta e is equal to 0. If you make theta e is equal to 0, then only you can say that phi dr is basically equal to phi r and phi qr is basically equal to 0. Is it clear? Phi qr is basically equal to 0 because no component of the rotor flux is acting along the q-axis rotor. Okay, now is it clear now? Okay, so now let's draw the block diagram. Draw the block diagram. In the input, you have what are the input variables you are having? What are the input variables you are having? You have IDS, IQS because it's very difficult. You don't have IDR, IQR. Why? Because IDR and IQR are the two rotor currents actually. D axis and the Q axis rotor current. And D axis and Q axis rotor current comes from the IABCR, means A, AR, BR, and CR. From these three variables, if you can measure this AR, BR, and CR, then only you can measure, then only you can, if you transform it, then only you can get IDR and IQR. So ultimately, you say that in order to measure IDR and IQR, you need to place a sensor inside the rotor, which is very difficult. Okay, because the rotor of the machine, of any kind of machine, is basically rotating in nature. Okay, now, but IDS and IQS you can easily measure. IDS and IQS comes from the transformation of the ABC to DQ transformation of IA, IB, and IC. Okay, IAS, IBS, and ICS. Stator current. Because stator is stationary, you can easily measure the stator current IABCS by using some Hall effect sensors. Okay, now. So ultimately, what are the variables which are in front of you? IDS and IQS you can easily get by using current sensors. Okay, IDS and IQS is in front of you, is in your hand. Then after you have to, only these two variables are in your hand and you'll have to express the other things in terms of these two quantities. RS plus of sigma. This one is what? This one is what? This one? This is basically your leakage inductance. Okay, leakage factor also you can say, not leakage inductance, leakage factor. If the rotor and the stator of the induction machine is very tightly bounded, then you can say that the leakage inductance is basically 0, and thereby you can say that this quantity sigma is also 0. Okay, so this one is the leakage factor. Sigma LSP. Multiplying this IDS into RS plus of sigma LSP, just see it whether the equations are correct or not. If you go by this type of equations, in order to simulate it in MATLAB, this here it is minus, here it is plus. Okay, and you have VDS also in front of you. Okay, VDS. What you'll get? Multiply it with LM by LR, LR by LM, multiply it with LR by LM. You get what? P side DR. Okay, now, isn't it? Because P side DR, the equation is what? You have derived it. P side DR, if you have derived it, I really don't know whether you have derived it or not. P side DR, I feel. No, this is not the equation of P side DR. Oh, yes. P side DR, I feel this one is, yes, see here. P side DR is having this type of equation. Okay. Okay, P side DR is having this type of equation. Then how can you derive this one? Is it clear or not to you? I'll be telling you why this equation is correct. Okay, so from this one you get P side DR. Okay, integrating this quantity, P is the differential operator. Integration of it will give you what? Side DR. DR. Okay, side DR. This one will be a very bigger one. So I can take a scan of it and then after I can upload it. Okay, let me just wait for 1 second. Let me upload this one. This one is a very bigger diagram. Just let me scan the diagram first. Just wait. Just scan the diagram. Just see the diagram once. Just wait 1 second. Now I can see it. Now is this diagram visible? This diagram is visible. Yes, no? I'm trying to rotate this diagram. Rotate it. Now see this diagram. See, this one is IDS, this one is VQS, VDS. Okay, so RS plus of sigma LSP is basically what? IDS into RS plus of sigma LSP. Means here from what do you get from this timeline? How do you get VDS minus of RS, VDS minus of IDS into RS plus of sigma LSP? Isn't it or not? In this terminal, from this point, what do you get? From this point, you get basically what is the equation? From this point, you get VDS minus of RS plus of L plus of sigma LSP into IDS. You get it? Okay, now? And that one is basically equal to what? That one is basically equal to your P5DR actually. Isn't it or not?
Sir,
Tell me.
sir, Chinmay is waiting to join here. He's
Chinmay is waiting to join. Chinmay is waiting to join. Okay, Chinmay, okay. See, whether this diagram is clear to you or not, just tell me. See, those who have written the equations, one equation was there, VDS is basically equal to RS into IDS plus of sigma LS P IDS, isn't it? Because you know phi ds, previously I have taught you today's class only. Phi ds is basically equal to sigma ls into ids plus of lm by lr into phi dr. Substituting this value in the expression of the VDS, you get VDS is basically equal to rs into ids p plus of sigma ls into p ids plus of lm by lr into p phi dr. Correct or not? Not correct. Okay. Let me show you then. Class interaction is always better. Okay. So you know, in the morning session I have discussed that this equation. See, whether this equation is correct or not, you tell me. In the morning only I have discussed these two equations. VDS is equal to RS into IDS plus of RS into IDS plus of sigma into LS. This is not sigma actually. LS P IDS plus of LM by LR into P phi dr. If you make this one, if you shift it to this side, okay, then the P phi dr will come out to what? VDR minus of VDR means the whole thing LM by LR, sorry, LR by LM into VDS minus of RS IDS minus of sigma LS P IDS is basically equal to P phi dr. Isn't it? Isn't it or not? Just observe these two equations. Correct or not? These equations are visible or not? These two equations are visible or not?
Yes,
visible, na? So from this one you can easily say. that this equation that VDS minus of IDS into RS plus of sigma LSP into LR by LM is basically equal to P phi dr. Correct or not? Up to this much, have you understood why it is coming? Subhasri?
Yes, sir.
Understood na? Sachin, understood na?
Yes, sir.
Okay. And then
Sir, can you please repeat this part once?
see. Yes, definitely I will repeat. See, these two equations, have you understood these two equations? These
Yes,
two
sir.
equations right in the morning.
Yeah.
So you can say that from this equation you can easily say, if I erase it a little bit, if I erase this one a little bit, if I erase this one a little bit, just wait for a second. Here only I am doing the rough work. If you erase this one a little bit. See, if you erase this one a little bit, so you can say that P from this equation I'm telling. This equation, get this equation. P phi dr is basically equal to sorry, LR by LM, isn't it? The VDS minus of RS plus of sigma LF P I TS. Correct or not?
Yes, sir.
Correct na?
Mhm.
Okay, now move to correct or not? Correct na?
Yes, sir.
Yes, sir.
Okay. From this equation also you can get the expression of the P phi dr, IQR, P phi QR also you can get likewise. Okay, correct or not? Okay, now you observe this block diagram. See here, this one is IDS. Okay, this one is VDS. And here in between, this one is minus and this one is plus. So ultimately from this part, what does it come? VGS minus of, because this one is plus. So here it will be what? VGS minus of IDS into RS plus of sigma LSP. Okay, multiplied by LM by LR is basically equal to P phi TR. Correct? Likewise, here also you can derive the expression of the P phi QR also. P phi QR also. After that, integrating these two, you get phi dr and phi QR. Okay with it? Integration of this P phi dr and P phi QR, you get phi dr and phi QR. Okay with it? Now, you need to measure the speed. So ultimately, so in the speed expression, the omega r expression was what? Omega r was having this expression. Omega r is having this expression. What is the expression of the omega r? Omega r is having this expression, isn't it? Omega r is equal to phi dr into P phi QR. P phi QR you have already derived. P phi dr you have already drawn the block diagram. Okay, so this equation is well known to you. And here you have phi dr square plus a phi QR square, isn't it? You need to express this omega r. Okay, what you do is that just observe this one. You need to get the phi dr square and phi QR square. How can you get it? See, this one is phi dr, so here also you get it phi dr. So phi dr into phi dr. This one is same thing, you are multiplying it. This one is the multiplier block. Phi dr into phi dr, you will get phi dr square. Likewise, this one is phi QR, so this one is also phi QR. So phi QR into phi QR, you get phi QR square. Phi QR square over here. You have to divide this one. Okay, leave it. Moreover, P phi dr into P phi dr multiplied by phi QR. Isn't it? Expression of the omega r was what? Phi dr into P phi QR minus of phi QR into P phi dr minus of Lm by Zr whole thing bracket phi dr into IQS minus of phi QR into IDS. That's it. Okay, now. So you can express this one by this simple expression. Up to this one, is there any problem? This block diagram. Just observe the block diagram and match the equations. Is it clear?
Yes, sir.
It's not clear, na?
Sir, actually, I need to go through that whole diagram.
Go through the whole diagram, na? I'll have to reduce the zoom. Actually, I have to reduce, na? Now it is visible, na? See here. Here from you get P phi dr. Here from you get P phi QR. Integrating it, you get phi dr and phi QR. And again, in the expression of the omega r, you have what? Phi dr square plus a phi QR square. Omega r expression, you just write it in your copy. Okay, and just match it. Okay, the whole thing will be divided by. So see what in the downward you'll have to see. I mean, if I can make share these two slides parallelly, then it will be better actually. But okay, I will have to find out some ways. See, in the expression of the omega r, you have phi dr square. Phi dr is what? Phi dr into phi dr. Phi QR is phi QR into phi QR. Whole thing will be plus, and the whole thing will be divided actually, isn't it? See, here also same thing happens in this block diagram I am saying. See, here you get phi dr, here from you get phi QR, sum it and then divide. This one is divider. D stands for divide. Okay, now better. And from this one, you get what? You get the total upper part. you get total upper part. See the upper part, you have LM, see the expression. The expression, okay. Achin, you please tell me the expression.
Sir,
Pi,
yeah, omega r expression, sir.
exactly. Pi
Pi
dr,
dr P
P phi QR,
QR minus phi
minus
QR
of P, yes, phi QR, P
phi
phi
dr
dr, minus
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 Lm
of
by Zr
LM by ZR into phi
into phi
Q,
dr
phi dr,
IQS
IQS, good.
minus phi QR IDS
Divided by the whole thing.
phi d square plus phi QR square.
Very good. So that expression is only expressed over here. That expression is only expressed over here. How? See, in that expression in the second term, see, if you okay, let me do it a little bit simple because if you're not able to understand what I'm trying to say, it'll get bored if you can't understand this thing. This is supposed to be term one. This is supposed to be what? Term one. Supposed to be one number term. This is supposed to be two number term two. This is supposed to be term three. And this is supposed to be term four. Okay. Now look at the equation. Here from you get phi dr into P phi QR. Phi dr into P phi QR. This one is P phi QR. This one is P phi QR. And this one is phi dr. See here, these two are multiplied. And this one is minus. Okay, isn't it? Then P phi QR in P phi, sorry, phi QR into, see here, phi QR into P phi dr. This one will be minus. Okay. So this whole thing is your term one. Here from you get here actually you get term one. Where do you get term four? Term four you get here. This output of the divider you get term four. Where do you get term three? Term three is Lm by Zr. That's it. Okay, term three is this one. Lm by Zr. Okay, into multiplied by phi dr. Phi dr is this quantity. Phi dr into IQS. Okay, minus of pi QR into IDS. That's it. Is this block diagram clear now? Or I'll have to draw it line by line. I'll have to draw it in board now. This diagram. Where if this diagram is not clear, you'll face a little bit problem actually. Let me draw it.
Sir, that part phi, psi, QR and IDS, where it is?
Which one? Which one? Tell me. Subhasri, please tell me.
Term 2, sir.
That second one.
Second one? See here, phi dr is this one. Second term is what? Lm by Zr is your, sorry, second term is which term?
Psi
dr
QR
into
into
IQS.
IDS, yes.
Phi dr into IQS minus of phi QR into IDS. Sorry, phi dr into IQS minus of phi QR into IDS. That's it, na?
Yes.
That term, see here, phi dr multiply. This block is multiplier block. This is also multiplier block. So phi dr into IQS. IQS you get from where? Here, IQS is your machine terminal variable which you can easily get. Actually, from the machine you can easily get IDS, IQS, VDS, VKS. That's it. Because these all are the stator voltage and current that you can measure it by your voltage and current sensor. Okay. By using these four variables, you'll have to estimate or you'll have to determine the equation of the omega r so that you can estimate it. There is no need of speed encoder. Okay. So here you can say that this one is IDS, phi dr into IQS, and here you get pi QR into IDS. Okay, this whole two things will be this one is your phi dr, na? This one is the plus and this one is the minus. Okay, multiply it with Lm by Zr, you can get this one. Clear now?
Yes, sir.
If you are facing any problem, I will discuss it in board also. So open loop vector control is over now. Okay. So in the next class, I'll be teaching you the closed loop vector control, because this thing you just study in home. Otherwise I can't proceed further. You just check this diagram a little bit. Okay, you can scan it or I'll upload it today. First of all, check it once. Okay, first of all, try to learn it once, and then after I'll be moving on to the closed loop. Today I will not move to the closed loop. Okay, fine.
Okay, sir.
Thank you.